All right, welcome back, everyone. Hope everyone had a nice weekend. Enjoyed the nice weather. I know I did. Spent some time outside, so it's real nice. Guys, today we're going to talk about surface area of pyramids. Guys, we'll hit cones tomorrow, so just focusing on the pyramids today. Lateral area as well as surface area. So, guys, a regular pyramid, guys, it has a base that is a regular polygon. Guys, we're either going to look at rectangular pyramids, where the base is a rectangle. We might look at a triangular pyramid, where the base, the bottom piece, would be a triangle. But those are the two ones we'll really focus on. We won't look at anything too strange. I'll show you an example of what one would look like, but we won't even do the problem. Just focusing on rectangular or triangular pyramids. Okay, guys, slant height. So let me erase those last drawings I've got. Slant height of a pyramid. So if you're standing at the pyramids of Giza, okay, the slant height is that measure that you would go. So if you're right at the base and you walked up, or you drug a ruler all the way to the point of the pyramid, okay, it measures it on the slant, on the slope of one of the sides. That is the slant height. It is perpendicular to a base, though. Okay, guys, we're not going to worry too much about non-regular pyramids, so just focusing on regular pyramids here. So lateral area of a regular pyramid, L lateral area, is 1/2 P, where that's the P is the perimeter of the base, times L, which is slant height. Okay, 1/2 perimeter of the base, P, times L. So if we're finding the lateral area of the square pyramid, we're going to use 1/2 perimeter of the base times, back that up, need to use my cursor, times L, slant height. Guys, the base is a square. Now, one side of the square is 4 inches. So the perimeter of the base, the P, is going to be 16 inches. The slant height here is 6 inches. That's the measure they've given us. All right. So lateral area is 1/2 times 16 times 6. 1/2 times 16 is 8. 8 by 6 is 48. And being a measure of area, that's units squared. So 48 inches squared here. Okay. So that's lateral area of a pyramid. The next one, word problem. Oh, in fact, it's talking about hexagonal pyramid. So let's just change it to, let's not worry about this one. Okay. Actually, let me just attempt to draw. This is going to be probably pretty ugly. I'm not even sure where we're going to, how do they kind of, let's have this triangular pyramid. Let's say it's an equilateral triangle, though. Make our lives a little easier. The base is an equilateral triangle. Let's say it has side lengths of 3 inches. And let's say the slant height, let me get another color here. Let's say that slant height down the front here, let's say that is 14 inches. Okay, let's find the lateral area of this pyramid, just for a practice problem. So lateral area, 1/2 P times L. Guys, the perimeter is a equilateral. Sorry, the perimeter of an equilateral triangle. We're just adding 3 plus 3 plus 3. So 9 times slant height of 14. 1/2 times 14 would be 7. 7 times 9. We'd be looking at 63 inches squared for this pyramid. Okay, so 2 lateral areas, guys. We're not going to do hexagonal pyramids. We haven't talked a great deal about those. Okay, surface area of a regular pyramid. So, guys, just like with prisms, the surface area is the lateral area plus, well, in this case, there's only one base, so plus B, the area of the base. Okay, of course, we know that L, and that's what you see reflected in here, that's just 1/2 P times slant height, 1/2 perimeter of the base times slant height. So this would be the formula I'll be plugging into. All right, so find the surface area of the square pyramid. So we're going to go 1/2. Surface area is 1/2 perimeter of the base times slant height plus area of the base. Square pyramid, guys, the area of the base, 12 times 12, 144 centimeters squared. The perimeter of the base, 12 plus 12 plus 12 plus 12, 48 centimeters. Guys, the slant height, we're not given the slant height here. So we'll need to find it. That's the only part of the formula we don't have. We're given the altitude, or the sometimes called the height of the pyramid, measured from the center of the base to the point. But what is drawn there, and I kind of tried to highlight that, is this right triangle. We've got a 16 inches. Guys, that's the center of the base. So if that length across is going to be 12 centimeters, well then half of that is 6 centimeters. Sorry, I'm mixing up units here, guys. And so that's our slant height. So this is just a Pythagorean theorem problem. 16 squared plus 6 squared equals L squared, the hypotenuse squared. 16 and 6, 16 squared, 2, I don't know, I gotta get my calculator out, guys, apologize here. Give me just a minute. $256 and what, 6 squared is 36. So 292 equals L squared. We square root 292, and we're gonna get well, let's plug it in. Let's call it the square root of 292. Plug it in all at once here. 1/2 perimeter of the base we said was 48 times the square root of 292. We can plug that into our scientific calculators. Plus, I wrote B there. Plus 144 was B. All right. 1/2 of 48. That's 24 times square root of 292. I'm going to my calculator again here, guys. 24 times square root 292. That's 410.11 plus 144. And that's going to be equal to 554.11. Units were centimeters squared. That is the surface area. All right. So, guys, with these regular pyramids, guys, that'd be a fair problem, certainly, where you had to use that Pythagorean theorem there. Square root of 292 being irrational might throw a few of you for a loop, but totally fair game, I think. So that's that, guys. I did say I would show you a kind of a pyramid with a regular polygon as the base. Well, this is a hexagon. So a regular hexagon here was the base. So again, not going to worry a great deal about that. All right. So guys, any questions about surface area of pyramids, fire them my way. Send a message, post in the discussions, guys. Other than that, have a wonderful afternoon.